All right, welcome to class, everyone. So today we'll be looking at polynomials, and your polynomials come in different ways. We're going to start with the first thing we're going to learn under your polynomials. We should be looking at. So for polynomials, there are key things, and we're going to take it just that way, right? So we'll be looking at one. We should look at subject of formula, right? Change of subject of formula. I'm going to look at change of subject of formula. Then after that, we'll look at your factor and remainder theorem. Then we'll look at factorization of polynomials of degrees that are not greater than 3. Right? Factorization. I'm writing this thing so that anywhere we stop, you can continue the work from there. Factorization of polynomials. Right? And it's for degrees not greater than yeah, I think within that line, I think degree not less than or greater than 3, if I can remember vividly. Now the next one again that you should look at, you should also look at we also look at multiplication and division of polynomials, right? Multiplication and division of polynomials. Right. So these are key things you should learn under your polynomials, right? Then the next one is you also look at the roots of polynomials, how to get the roots. This is for pay attention to degrees not exceeding 3, right? Right. So degrees not degrees, how will I put this in variables form? So degrees less than or equal to 3. Is that okay? So it shouldn't be more than 3, right? Degrees not exceeding 3. Now also look at the roots of what? The roots of polynomials, how to factorize your polynomials. So just go ahead and check that and ensure you learn them. So roots of polynomials not exceeding, when I mean degree of 3, you know what implies, right? Not exceeding degree 3. You know what that means? That means the highest power should be 3. Are you there, guys? A thumbs up if you're hearing me.
Yes,
So the
yes.
high, yeah, good. So the highest power is going to be 3. That's the kind of polynomial you should be looking at. You should be looking at factorizing. Now, the next part of things you should as well observe as you are reading, I'm giving you everything. I'm not writing here just so that you can go and keep it. It's for you to go ahead and work things on that. Is simultaneous equations. You know, in your junior secondary school, they taught you simultaneous equations for linear equations in particular, where you use your elimination method or substitution method. But this time around, it's simultaneous equations including you have one linear equation. You know what is a linear equation, right? Including one linear, one linear, and one quadratic. What do I mean by one linear, one quadratic? Now, a linear equation, the power of a linear equation is 1. So that's what I mean by linear equation. And then one quadratic that has x raised power 2. So you're going to be seeing things like highest power, linear equation, the degree, x is 1, right? So quadratics is the one that has 2. So they're going to combine two equations that are quadratic equations and one that is a linear equation, and you're expected to solve them simultaneously, right? So all of those ones you can still learn via your YouTube to ensure that you catch up with all of these topics. Then the next one is now the graph of your polynomials, right? So once you get this material, anywhere we stop today, ensure that you cover up. Is that okay?
All right.
Yeah, so graph of polynomials of degree Though we should have 3 classes this week for maths, so we can cover up for last week. Not greater than 3. All right, so that's for that. Let's start with our change of subject or formula. Hope we are all on the same page. So now let's start with change of subject or formula. So I have some questions here, which is your past question. I wish I can import them, but it's going to take us time. So let me just get started. So now let's look at change of subject or formula. So when you hear change of subject or formula, what are you doing? Right? It's just like expressing a particular term in with reference to other ones. Example, when you learned your physics and they were teaching you how to get you are trying to get the density of a body, right? So from the density, remember that density is mass over volume. Is that also? Remember that density, recall, density is mass over volume. So you have something like density equal mass over volume, right? As explained to us. So recall this. Now the girls they've created their own group and they are doing amazingly well in that group. But all these men, these old men in this boot camp, they don't want to create, they are waiting for one person that will do it. Now, so density is mass over volume. If you want to look for mass, you now have that mass is equal to density times by volume. What that implies is that you've made mass the subject of formula. Do you understand? So this very part simply implies you've made mass the subject of formula, right? So now mass has been made the variable mass. Let me put it like that. The quantity, okay, mass, we'll call it variable actually. So the variable mass, right, has been made the subject of formula. Has been made the subject of formula. Has been made the subject of formula. Now, likewise, you can get that of density as well, right? So when you say that density, sorry, not density, I mean, I wanted to say volume, right? But you know how mathematics can be. These ones are just your physics quantities. So for volume now, volume is going to be equal to what? When you cross multiply, it's going to be what? Mass over density. Is that also? Is that also? So mass over density. So you see that we've made what? Density the what? The volume, the mass of the subject of formula, right? So here, volume, subject. Someone's mic is on. Who is that? So volume is the subject of formula. Now let's look at your past questions and let's see what we have right here. So JAMB 2010. I wish I can import these things. All right. Give me a few minutes. Let me import it. I think it will be faster for us so that you see what the questions looks like, kind of. Let me just write. I'll be fast. So now we'll have your JAMB 2010. So your own role, the only thing you need to do is to ensure you are making use of the rules of mathematics. Anything that you can do to get to that very thing they want to get for you is entirely fine. That is one thing about mathematics. Apply the rules, play around. While in school, we'll call it acrobatics. Apply any acrobatics you can apply, ensuring that you are following the rules of mathematics just to make whatever thing they want to make the Schrödinger formula, right? Apply the rules and get your answer. So here they said make Q the subject, make Q the subject of formula, make Q subject of formula when L is equal to, we'll have 4 over 3, then we'll have M. Observe how the equation looks like. Then you have PQ. They gave us interesting options. They said that first one is 9L squared. And sometimes you have to After factorizing or after making them shape the formula, you have to rearrange your answer so it can suit whatever option that they give to you. Sometimes it can be challenging to do that, but once you know your onion, you should be able to do that. So 4m, then square root of p. Now the next one is square root of 3l, then all over 4mp. Then the last one, they said 3l squared all over 16m squared. Then you have p right here. So what do we do? The only thing we can do is that we're going to solve. So let's make L the subject of formula as fast as we can. I will solve just 3 questions and I'll go over to factor and remainder theorem. Then I'll show you how to divide polynomials as well and how to multiply them. I think if you know how to divide, you should be able to multiply. So now, what will be our solution now? So solution. This was given to us and we're looking at making Q subject of formula. Now, anything that will make your work easier for you is entirely fine. There's no rule to this. There's no particular rule to this. So for me, the first thing I want to do is I want to put these things together because they are together actually. So I want to say that L is equal to, I want to multiply. So 4m square root of what? PQ all to the power of 3. That's the first thing I want to do. Now I want to introduce over 1 here so that I can cross multiply. If you are confused at any point, please let me know. Now, the next step, I want to cross multiply. So let me write my step here. Let's cross multiply. So if I cross multiply, I'm going to have that this is what 3l is equal to 4m square root of pq. Remember my goal. I want to isolate q. I want q to be alone. So the next thing I'm going to do, let's divide both sides by the coefficient of 4m so that I can now have only square root of pq by the right hand side. So now divide both sides by the coefficient of square root of what? PQ. And the coefficient of that very number is your 4m. So I should have 3l all over what? 4m is equal to 4m square root of PQ. Divide both sides by your 4m. Now I'm going to cancel out as always. So this guy will go, this guy will go. Now we are left with something here, which I can rearrange as your square root of PQ. It's equal to 3L all over what? 4M. Remember, our goal is to make Q the subject of the formula. And because of that, what do? I'm going to take the square of both sides because from your indices, square root of PQ is the same thing as saying PQ to the power of what? 1 over 2. It's equal to, and thank God we've done indices. Nobody will tell me that he or she is confused about this. So this is 3L all over what? 4M. Because I want to remove this 1 over 2, I'm going to square both sides. So square both sides. When I square both sides, I'm expected to have something like PQ to the power of 1 over 2. Because I'm squaring both sides, something interesting is going to happen right here. So I take all squared right here. Then this is equal to 3L all over 4M. I'm also squaring that side of the equation. If you're still with me so far, can I get a thumbs up, please? So all squared. If you're following, a thumbs up. Beautiful. Now, having done that, you would see something quite interesting again. You're going to see, if you observe properly, that this will cancel this based on the laws of your indices. When you open that bracket, you now have that PQ is equal to what? 3L all over what? 4M I can still leave my all squared right here. Now I'm looking for Q, but Q is attached to P. So what am I expected to do so that P will no longer be attached to Q? So I'm going to divide both sides by P. Divide both sides by P. Now, when I divide both sides by P, for us not to get confused, we can have PQ. Remember, in the exam hall, you shouldn't be as detailed as this. Nobody's giving you mark for being detailed. If I'm solving this question in the exam, trust me, I'm done by now. So this is 3L, then 4M all squared divided by P. And like we know, you learned in primary school, if you went to primary school actually, because I think some of you didn't. But if you know you went to a good primary school, then you should be able to know that Q is equal to open bracket 3L to the power of what? 4M all squared. Then we invert all over what? All over P. Now at this point, I have to look at my options so that I know what next to do, whether I'm leaving my answer that way or there is more acrobatics to be done. Now, when I look at my options, I see that there is more acrobatics to be done. I have to open up that bracket. Now, open up that bracket, we have to distribute the power, which is 2. Now, that simply means I have that Q is equal to, open up that bracket, 3 squared, L squared, open bracket, 4 squared, and M squared, all multiplied by what? It is being multiplied by what? 1 over P. So therefore, that implies, men and brethren, that Q is equal to 9 squared is 9, L squared is L squared, 4 squared is 16, then this is M squared, right? So if you observe our options, which one do you think will go? So I can bring in my P right here. Hence, we've actually made our Q the subject of formula, and we can now go ahead to pick our option, and that option happens to be what? The option happens to be a D. Is it D or A? Sorry, an A. Does it make sense, guys? Are we all on the same page? So it's about, there's no particular defined rule. Another person can use a different method, but the main thing is to ensure that any rule you're applying is not against the rule of mathematics. Are we together, guys? Can you give me a thumbs up so we can go to the next example real quick? If you have a question, you can
So,
ask, but I think, okay,
yes, I want to ask you a question. I
go
thought
ahead,
that three
Mano.
enlo, I thought that three enlo when they square it,
Mm-hmm,
so that
mm-hmm.
that three and enlo is together, so that when you take the square root of both sides, it will be nine enlo without any square
No,
of the n on
oh,
enlo.
okay. That square is actually for both of them. Okay, he's asking this question that he was thinking that these three L, like more that they are together, so these two will just go for them as like being together, right? That's what I'm trying to say. For example, we should treat 3L to be something like A, so that score will be for them. And I'm going to have just 9L. Is that what you're trying to say?
Yes,
Yeah, I think I get that.
yes, yes.
Beautiful. All right. But remember, we'll call it the product power law. The product power law, when we had two variables, A and B, all to the power of 2, they are two separate variables. A and B are not the same, they are separate. And because they are separate, the power is going to be distributed. So therefore, this will give us what? A squared and B squared. Because they are two separate entities, A and B. Same thing applicable to 3L. Let's say I have raised to power 3. I'm going to distribute the powers. So this means 3 raised to power 3 and L raised to power 3. So 3 power 3, then L power 3. Does it make sense now? So you are distributing the powers according to the product power law. All right. So always take note. I think key things that you need to know when doing your subject of formula is your indices. The law of indices is so important as long as mathematics is concerned, because it's something that you will need at every point in time. Now, the next question I have right here, I wish I should just send the screenshot to the group. Then the next one is, we should make Q. I don't know. Is it that they wedded with Q or something? Everywhere is Q. So why is it like that? This one also has to do with Q as well. I don't know the covenant they had with Q. So they said this is your jump a little bit back. That is 1997. So this one said they should make Q, but this time around the small q, make Q the subject of the formula, the subject, okay, they call it the relation this time, subject of the relation. And what is that relation? They said that T is equal to, what I don't know is if the square root is for all of them. Look at the way they wrote it. T is equal to, they have something this way, and they have comma P, Q, R. Okay, all of them are in a bracket minus R squared Q. So I think that square root should be for all of them, right? And they gave us the options. A, they said Q is equal to RT squared over P minus R3. Then you close up the brackets. Now you have the B part of things. And for the B part of things, you have that Q equal, let me create a new slide. So I'm solving just 3 questions on this, and I move over to the remainder theorem and factor theorem and divisions as well. So this is T, they said T squared all over, you have your P minus R squared, close brackets. Then the C part of things will have Q equal to, you have your RT divided by, you have P minus R cube, you close the brackets. Now you have the D part of things. So this is Q equal to, you have P minus R cube all over RT squared. Then finally, you have the value, which is your E. E is simply your Q equal RT squared P minus R3. So let's get our hands dirty here and see what happens right here. So I think the third one, we're going to solve, everybody will solve, get your answers, and before I will solve. All right, so let's see what this one is going to be, and let's see how it goes. So let's have our solution right here, and let's see what happens here. Now I'm going to copy this, and I'm going to go away to paste it right here. So what will I do? First of all, let's rewrite this in a way that we understand it better. So this is T is equal to, right? It should be all squared at this point. So everything should be squared. I think that's what that very question is trying to say. Then we have P Q R minus R squared Q. Now, the first thing I want you to do is to remove this square root. Once you remove this square root, it makes things easier for you, because sometimes people can be scared about this word. Once they see cube or square, it becomes kind of scary for them. So the first thing I'm going to do is to introduce what I know regarding my indices. I know that this is something as what? 1 over 2. Now I'm going to square both sides so that that 1 over 2 will be dealt with. So square both sides. So let's square both sides and deal with that very guy so that we don't have anything to do with any squared whatsoever. That done, we should have T, but this time around, the T will now receive a square, right, which is now equal to the whole of this place. We'll still have our PQR minus R squared Q 1 over 2, but this time we're introducing something quite interesting, and that is that we are squaring everything right here, squared. Now, if you have your mathematical eyes, you will see that 2, we cancel 2 right here, and that done, we have something quite interesting here, and that is that T squared is equal to what? PQR minus R squared Q. Now, we have to factorize. We have to factorize. So based on your mathematical eyes, you will see that they have something in common right here, for some of you that do. So you have your Q right here, it has Q here, it has R, and it has R here as well. So they have something in common. And because of that, we can easily do what? We can factorize. Let's factorize using our ego eye. So when I factorize, I should have that T squared is equal to, I'm bringing out Q, which happens to be the common term. So I'm bringing out Q, I'm bringing out R. And when I do, you're going to have that QR divided by QR. We're going to be left with what? Just P minus. So QR divided by R squared Q. We're going to be left with just R remaining right there. So, but remember that our goal is that we want Q to stand alone. So we're going to divide both sides by this coefficient of Q. So divide both sides by the coefficient of Q. Divide both sides by the coefficient of Q. And eventually, when we divide both sides by the coefficient of Q, we are going to divide through by R right there. All right. Okay. So that means that we should have this at this point. We have, sorry guys, we are going to have t squared divided by rp minus r is equal to, I still have my qr, I have p minus r divided by what? rp minus r. So that said, the whole of this can go. Yeah, anybody still following me at this point? Do we have men and brethren that are still following at this point? A thumbs up if
Yes.
you are still following. All right, beautiful, beautiful. So mass is quite interesting, quite interesting. So let's have that Q at this point is equal to t squared, open brackets. It's not good to leave our, let's look at the option and see whether I should expand further. The option will determine what I'm going to do right there. Option will determine what I'm going to do right there. Since I have r squared q, I factored out r, and when I factored out qr, I'm going to have p minus q remaining. We've divided both sides, so we have t squared r p minus r. So do we have anything similar to what I have currently in the option? Is there anything similar to that we have right there? T squared. Do we have anything that way? Do we? Oh, this I've seen there's a mistake here. This is P slash Q, the question I copied. My God. Sorry about this. So there is a slash here, please. Sorry, PQ slash R. Are you there now? There's a slash there. It's because of the way they wrote that question. So that means I'm going to make some corrections right here. So there should be a slash here. Guys, are you with me? So sorry about that big error right there. So this is PQ. There is a slash R here. So there is a slash here. There is a slash here. So which means if I'm to correct that, this should be written like this, guys. This is PQ all over R. A thumbs up if you are still with me. Sorry for that mistake. A thumbs up if you are still with me. Okay. All right. So that said, I should now look at what should be factored right here, because this place should be PQ over R. This is PQ all over R minus R squared, which means I'm going to take a different approach now. Permit me to do that, right? Here is over 1. Here is over 1. So before I factorize, let me add a new page before I factorize. So sorry, guys. That's mathematics. Any small error, it reflects in every other thing. So before I factorize, let me add those two fractions together. So this is t squared is equal to, remember that for you to add fractions together, they should have the same denominator. Or add or subtract, they should have the same denominator. So I want to apply my equivalent fraction. This is pq all over r minus r squared q times r all over what? R times 1. That is the rule of mathematics. For you to be able to subtract or add fractions together, they should have the same denominator. So I introduce r there. R can still cancel r. Is it confusing, guys? Equivalent fractions. You understand it, right? Yeah, men in the house, you
Yes.
understand, right? Okay, beautiful.
Yes.
So that means that t squared now is equal to pq minus r squared q all over what? All over r. Good. Now, with this, we can now cross multiply before we start factorizing. So just cross multiply. When I cross multiply, I should have t squared r is equal to pq minus r squared q. Now I think at this point is when we can now factorize, and that thing I solved will now make sense. So let's factorize. So factorize q. When I factorize q, I should have t squared r is equal to, let's bring out master q. Then when I do, I should have open brackets p minus r squared. Now we can now divide both sides by the coefficient of q. Divide both sides by the coefficient of q. All right. So when I do, we are going to have something amazing. T squared over r divided by what? P minus r squared is equal to what? Q p minus r squared, close bracket, all over p minus r squared. Okay, so let me go ahead and divide both sides. Now here we rule out. Justice, have you filled the form we sent to the group chat?
No.
I know. I know you've not. After this class, you have 5 minutes to do that. Else I will call police for you. I will arrest you. Justice. You are laughing, Abby. Please remember to do that. I might not remember to tell you again. Just remember to do that. So maybe I will forget, but then ensure you do that. So let's check our options then. It's very important to us. So now let's check. We have which one goes now. Hope my answer is in the option.
B should be the answer.
Is it B? Okay. T squared over P minus R squared. But I have R there now. T squared R. I have T squared. Okay, yeah. So B, yeah. Yeah. No, I have R under this place because I kind of cross multiplied. So I had R squared. So I factorized Q. Then their options, let's check their options again. Did I omit anything? RT squared P minus R T minus R squared. So let me delete this side first because this part is confusing me a bit. But is there any mistake? Did you guys notice any error from our calculations? Do we have any mistake from our calculations, guys? Yeah, there is, and I've seen it. And if we're not seeing it, young people, look at it now. R times R squared will give us R cube. Emmanuel and Co. This is R cube. So when you cross multiply, here is R cube. This is R cube. So please always pay attention so you don't make mistakes. So this is R cube. I beg in the name of God, because you'll be so confused and you might not even know how to trace your step. So this is 3 here. This is 3 here. So this is 3. So which option is that now? That should be option what? Option what is that? Option A, right? So this is option A. Option A. All clear, right, guys? This is option A. Why this one we solved earlier was option A as well. Wow, everything is option A. That's interesting. So this one is as well option A. Okay, now this time I'll give us this one to solve. Everybody get your hands dirty on that.
I think option A is not the correct answer for that second one because I can't see RQ on the denominator equation. Okay, sorry.
Okay, look at A. Yeah, have you seen it? Okay, makes sense. All right, so look at this one. Which one should I give you guys to solve? I'm looking at the one that is a bit okay. The first one by P. Okay, let me look at this. Is JAMB 2020, right? So let's see. You guys should solve this one. So JAMB. Okay, sorry, JAMB 2010 rather. So JAMB 2010. So this one said, make. Why is it this guy always making Q subject of formula? Are you sure the person that the name of the son is not Q? Okay, let me give you this guy, 2022. So JAM 2022, because I'm tired of the Q. So given that R is equal to the square root, the way since I'll go and buy JAM form. What do you guys think? I feel like buying JAM form just to go, just to go, but it has closed, right?
Yeah, it has closed.
And I should have bought JAM form just to go play around there, and see whether I can smash up to 370.
You are not writing to freestyle. I said you are not writing to freestyle, yo.
Exactly. So I think the only thing that will be a challenge is the English. But we'll just go there to freestyle with the maths, chemistry, and physics. The only challenge will be English, man. I should have registered though, right?
Is that MH?
I didn't hear you. You said?
Is it MH, the denominator?
Yes, this is pi.
Okay, pi.
This is pi, yeah. I should have registered actually. So make V the subject of formula. All right, so look at your option now. So give me your answers, guys. So V is equal to 3. Sorry, my pi might not be like pi, but then 3 pi r square h. Then you have B equal to V equal pi r h all over 3. Then C will be V equal pi r squared h all over 3. Then we'll have that D.
See the answer. See the answer.
C is the answer.
Yes.
Is it because you know the unit or because you solved it?
I solved this, sir.
You solved it. Okay. So Emmanuel, what's your own answer?
Is Emmanuel that reporting?
Okay, Emmanuel reporting. Okay. Justice, where's your own answer?
I'm solving it.
Okay. Faster, please. So Emmanuel, since you are done with that one more. So this one,
C.
C. Okay, everybody's getting the same answer, right? So let's quickly look at that. Then we'll solve one more and we are good to go, guys. So I'm going to be, this time around, no steps. So I'll just go straight. So this is solution here. No steps this time. All right. So we're making V subject of formula, right? So when I square both sides, I should have R squared equal to 3V. I should have pi H. Then this is over 1. So when I cross multiply, I should have 3V equal R squared pi H. Divide here by 3. Divide here by 3. You all said your answer is C. Is that what you said?
Yes.
Okay, yeah, C should be correct. So you have that V is equal to pi R squared H over 3. All right. Then finally, let's see what happens here, and let's see. This one is the last one, and there is your JAM 2022 as well. So JAM, is it JAM 2022? Is this okay? This is JAM, or rather, this is WAEC question. Oh. This is WAEC 2022. But all of them will suit what we are preparing for. So make T the subject of K in this, so make T sort of subject. You have the formula, you have K equal to M, right? You have the square root now. You have the square root right here. Then you have T minus P all over R, right? So option A, very fast, guys, so that we can move over to factor remainder theory. So plus B, then this is K squared. You have R plus PM squared all over M squared. Then C is K squared R minus P all over M squared. Then you have that D is K squared R plus P squared all over M squared. All right, guys, bring it on. Let's see.
So my answer is T is equal to K arrow minus P divided by M. But here,
No,
M is good. C should be answer, but M is good.
C is
But
answer, but
I'm
what happened?
I don't know. Let me take my step back.
Yeah, take your step. The options are correct anyway. That's what I told you. As you are solving, you are flipping things around. Is that okay?
Oh, sorry. I supposed to square the emu when I was squaring both sides because emu is on a different thing with the square root. So, but I squared them together. That's my mistake.
Okay. So what have you
The,
corrected it now?
the answer is C. Yes, the answer is C.
See. Yeah, is that Emmanuel or Justice? Who?
Emmanuel, Emmanuel.
Okay. Emmanuel said answer C. The next person.
C.
C. All right. So everybody, we agree that C is the answer, right? All right. So let's see. I'm not going to solve it. I'm just going to look at it. KR, yes. K should be squared. So KR squared, yes. So when you square both sides, move R to the other side, you are left with MT minus P. All right. But when you are squaring both sides, you should square M as well. So you guys said C, right?
Yes.
Did did you guys? I disagree with CO because the sign is going to change now. What do you mean? Look at it. Are you paying attention? When you solve, you square both sides. You should have something like this. I disagree with both of you. You have K squared, right here. Then M will be squared as well. Then you are left with T minus P all over R. When you cross over the other side, you now have K squared R equal to M squared. You have T minus P. Now you divide both sides by M squared. Is that not so? Is that not so? Are you there?
Yes.
Yeah, nobody's talking. Now, I go again. So you understand what I'm saying? I have K squared here equal to M squared, open bracket T minus P, since I've opened up my this thing, all over R. Now, when I cross multiply, I have K squared R is equal to M squared, open bracket T minus P. Now, I'll divide both sides by M squared. Now, when I do, I'm going to have, let me demarcate this line further. I'm going to have right here that you are left with K squared R over M squared is equal to T minus P. You want to make T sort of formula. So this will now be K squared R all over M squared plus P equal to T, because P will cross over now. So when it crosses over, what next can we do? We're going to add the fractions together. This is over 1. And I've taught you guys before, for you to add or subtract numbers, the denominators are going to be the same. So what am I going to do right here? So the next thing I'm going to do is to what? Open up. I will have K squared R over M squared. I'll multiply both sides. So I'll multiply here P times by M squared all over 1 times M squared, so that they can have the same denominator based on the equivalent fraction. Whatever you do to the up part, you do to the down part. Now remember that it is still equal to T. So I totally disagree with you guys. Now that said, we are going to now have k squared. Since they have the same denominator now, I can bring them together. Plus m squared divided by what? M squared is equal to t. So our answer should be A and not C. Is anybody confused?
I'm sorry, I'm not
Option
confused.
I
B.
know you that both sides.
Eh?
That m square, one times m square. I know you.
Are you confused about what I did
I,
there?
no, we are not confused, sir. Sorry, I'm not confused, but the thing is my mistake started when I didn't square MO and K while solving. So even when I flipped it to the
Okay.
other side, I did not put the sign. So that is it.
Okay. Remember that. Okay. I'm glad you've seen your error. I'm glad you guys are seeing your errors actually. All right. So remember what I did. I had to square both sides. Why am I squaring both sides? This guy, this is the way you are cancel this one. This one will collect 2 as well. Do you understand? That guy will collect 2 as well. So always pay attention to that when you are opening up a bracket. So this guy will have t minus p all over r. His square is still going to be with him. Any other question? Any other question?
No.
No.
Okay. So that is for your subject of formula, right? So let's quickly go and tick the one we've done now. So we've done change of subject of formula. Let's look at your factor and remainder theorem. So before I talk about factor, I will talk about the remainder theorem first because that will make things quite easier for us. All right. Then let me see whether I can add one more for you guys to just go and solve questions. Go online, go check past questions. So there's no need. Let's just proceed. All right. So let's look at factor and remainder theorem. If you are still with me, can I get a thumbs up, guys? Or rather, can I get a love emoji? So I can hold body. Justice, I know you, but you always give me you justice. I will report you to the appropriate authorities. Don't say I didn't say that. Hmm? I'm going to report you, bro. So let's look at factor and remainder theorem. All right. Now, for your factor and remainder theorem, let me take you back to primary school. When you were in year 5, that's primary 5, precisely, or even primary 4, or maybe even year 3, that's primary 3, as the case might be. Now, they gave you a number. Let's say you have something like, let's say 17, or let's use 19 actually. Let's say 19 divided by 2. Now, they will tell you, you should make use of your what? Your long division, right? Remember, what are you remembering? You are remembering your primary school days. Remember your primary school days. So they will tell you to draw something like this. Now you have 19 here. You have 2. 19 divided by 2 will give us what? 8. That should be 8. Is that also? 8 times 2. Is it 8? 9 rather. 9 times 2 is 18. So you put 9 here. Then 9 times 2, 18. You write 18 here. Then you now subtract. When you subtract, you draw your line, and then you have 1 right here. This is your long division method back in the days. You have 1 right here. You can also call it the bus stop method. Now, what are the key things you have here? You will remember that this one right here is what you called your quotient. This one was your quotient. This was your quotient. Is that not so? Now, also remember that this part was your remainder. I mean, for some of you that went to a good primary school, not those that went to the one that your teacher normally comes to school with a goosey that she will be removing the back. You know, I know people went to that kind. The woman will just carry the goosey to school and be peeling, they're removing the back of the whole thing while classes are going on. So we'll have quotient and then we'll have remainder. So we'll bring this together right here for your remainder. Now, recall that this part, this is what you call your divisor, right? The one dividing the number is your divisor. I hope everybody's following. Nobody's confused whatsoever because these are things you did back in primary school. So this is your what? This guy right here happens to be your divisor. This is your divisor. So which other one am I omitting? The next one I'm omitting is the number that is being divided, which we call what? What do we call it? What do we call the number that is being divided? Nobody's talking. It is called the dividend. I know you guys don't know it. That's why everybody just turned deaf and dumb.
No, sir, I wanted to speak dividend, but I'm not sure of it. So that's why.
All right, so that's your dividend, right? Now, if you observe something here, you're going to see something quite interesting here. That your dividend, are you paying attention now? Observe something quite interesting. You will see that your dividend is equal to, are you there? It's equal to your divisor multiplied by your quotient. Are you there? Plus what? The remainder. Now, let's apply it to what we have. The dividend is 19. So 19 equal to what? Divisor is 2. The quotient is 9 plus our remainder is 1. Is that not so? Is that not so? Good. So now, the same way that we can simplify or divide numbers, that is the same way we can divide polynomials, right? So the same way you can have a remainder after dividing a number, that's the same thing that goes for your factor and remainder theorem. Are we together, guys? Good. Now, it is a process that can be applied. And how do we go about it? Let's assume that we have something like this. Let's say we have something like this. Let's say we have okay. In the same way, are you there now? In the same way, polynomials can be divided. Are you seeing it now? In the same way, what can happen? In the same way, polynomials can be divided. I think before I talk about this factor and remainder theorem, I think it's important I show you how to divide polynomials. Once you understand how to divide polynomials, it becomes quite easier for you to understand the factor and remainder theorem. Now, the same way we divide numbers is the same way that polynomials can be divided. For example, now, example, let's say, please follow me gradually as we go to the promised land. Let's have x squared minus 5x plus 6 divided by x plus 1. We want to divide this by this. So what do we do at this point? to divide your polynomials, the same way we divide our numbers. Now, what we can do here is that the same process. Let's have our soludo, right? Solution. Hmm. Now, when we do, we have the same method pattern, the same pattern. We have x plus 1 right here, and you have x squared minus 5x plus 6. You divide it that same way that you divide your normal numbers. So now, let me show you the process. How do we divide? Let me rewrite this. X1, let me put my square root right here. Not square root, actually, that long division symbol. Then we have x squared minus 5x plus 6. Now, what serves, remember that this is your divisor, this is your quotient, is that not so? Sorry, this is your dividend, right? So remember that this our brother right here, this our brother right here, this guy, this our brother right here is your divisor. This our chief here is your dividend. The same way that you divide your normal numbers. That is the same process that works right here. So now that said, let's proceed. Now, what will be doing this division for you is your x. I want to explain what we call the remainder theorem. I want to explain what we call the what? The remainder theorem and the factor theorem. I'm going to introduce both of them, but I want you to see how it's related to division, right, of polynomials. Now, what we'll be dividing is your x. X is what you'll be using to divide through all of this. Now, the first thing you're going to do, you do x divided by x squared divided by x. That's the first thing you're going to do. X squared divided by x. That will give us x. Is that not so? So put down that x right here, the same way you do your long division method. X times x will give us what? X squared. My people, hope you are following. That will give us what? X squared. Again, x times 1, that will give us what? X. That will give us x. So plus x. Then after that, you do what? You subtract. The same way we do our long division method back then in primary school. When you do, you now rule a line as always. Now you bring down your plus 6. Minus times minus times plus is minus. So minus 5x minus x will give us minus 6x. Do you get that point? Can I continue? Then we'll go again. X divided by minus 6x. So you have x. Okay, sorry, minus 6x, I mean to say, divided by x. X will cancel x. We are left with what? Minus 6. So minus 6 times x, that will give us what? Minus 6x. Minus 6 times 1 will give us minus 6. As always, we do what? We subtract. Now, let's rule a line over here. Minus times minus is plus. Is that not so? Minus times minus is plus. So 6 plus 6 is going to give us what? 12 right here. Minus times minus here. Minus times minus is plus. Minus 6x plus 6x is 0. So we're going to be left with this. Note, what was simplified right here, we had minus 6x minus 6x. This is minus 6x plus 6x, which is equal 0. That's for the first one. Now, the next one that I did right there is that plus 6 minus 6x plus 6 plus 6 is equal to 12. So this was the mechanism or the process that gave us that very number right there, so we don't get confused. Everybody, is that okay? A thumbs up if you understand what I did now. A thumbs up if you understand what we did now. Sinos, why are you laughing?
Sir,
You are
I
confused.
believe yes, you.
Justice, are you confused as well? Okay, you get it right? All right.
I'm
So,
confused.
Chino, you are confused. Ah, so let's go again. We are trying to divide polynomials. So let's go again. Now, how do we divide polynomials? The first thing I'm going to do, I'm going to draw as if you are doing your long division, step by step. Now, I have, what am I dividing? I'm trying to divide x squared minus 5x plus 6. And I'm dividing by my divisor, which is what? X plus 1. And I said that what you'll be using to divide is x, right? So you pick, just the way we do your long division, the same process of doing your long division. X squared divided by x is what? So what I did here, right? Let me see if I can create a box here. So note, the first thing I did was x squared all over what? X. And this will give us equal to what? X. That's the first thing I did. So there is x here. Do you get that point now? Why I have x as my quotient here? Now, the next one, just the way you did your normal division now. Remember what we did for here now? You do 19 divided by 2 will give us 9. 9 times 2, 18. That same process of doing your long division. I think you should go back to your primary school long division. So it will make more sense to you. So now, x times x, you now start multiplying. X times x is going to give us what? X squared, right? X squared. Now, x times plus 1 is going to give us what? Plus x. Then we do what? We subtract. Now, for that subtraction, what we did there is that, let me rule a line here, is that we now did x squared minus x squared, which is equal to 0. Then minus 5x minus plus x. So this will give us minus 5x plus x, which is equal to x times 1. Yeah. So x times 1, that'll give you plus 1. Let me check my divisor once again. Hope I have not made mistake with my divisor. I think my divisor was x plus 1. Yeah, we're still on point. So I'm just trying to explain the process of what I'm doing, right? So let's have minus times plus is minus. Sorry, I think that's why I made the mistake here. So minus times plus is minus. So this is minus here. And that is how I got that to be equal to 6x. Do you understand? Do we understand it now? Can you give me a thumbs up to know? Okay, good, guys. Good. All right. So that said, the next thing I have to do is to simplify. Now there's nothing here now because we multiplied everything. There's nothing here. So you're going to bring down your plus 6. Just bring down your plus 6. Bring down your plus 6. This will give us what? Minus what? 6x. Now you go again. And going again simply entails that we're going to do Going again simply means we are going to multiply again now. So x divided by, let me write it here. I will explain entire today. Minus 6x divided by x.
But
It's
that minus 6s, where did they get it from? Is it
eh?
minus 5 plus that your minus 6x? Where did you get
Mm-hmm.
it from? Where did you get it
Look
from?
at it. Look, I explained it here now. Minus 5x,
Okay.
then there is minus sign here, minus plus x. So minus
Okay.
5x, minus times plus is minus. Bring your x, that will give me 6x. So you have minus
Okay.
6x divided by x now. Good. So that will give us what? Minus 6 here. And that is why the quotient here will now have minus 6. Then I go again. Minus 6 times minus times 6x times x, I need to say. That will give me, come on, teaching is not easy. My God. Oh God. So now, if I
Well,
multiply that minus 6 times x, I'm multiplying now. Minus 6 times x, that will give me what? Minus 6x. Then minus 6 times 1, that will give us minus 6. So now we want to do what? We want to subtract. Let me use color that will be brighter. So minus 6x, then minus what? 6. So what do I do right there? It's your normal simplification at this point. So when I simplify, let me rule a line here. Now, what do I have there? I'm trying to simplify. Remember that there's a negative sign right here. So simplifying that, I have minus 6x minus 6x. So minus 6x plus 6x, that will be equal to 0. Now, the next part of things is what? 6 minus 6. So that will give me 6 plus 6, which is equal to 12. And that's why I have 12 right here. Does it make sense? Don't worry, I'll solve more examples. The more examples I solve, the more sense it makes to you guys. So I want to label our answer right here. I want to label our answer. Now, labeling this answer, then I'll solve more questions on this. I'll solve more division problem, like 3 of them, so that you see the steps. So I want to label the answer so that you, because of this factor theorem I want to introduce. So when I label the answer, right, what are the key things I want us to know? Remember that here, this one right here is your quotient. Is that not so? This one here, this is your what? This is your quotient. This one right here, this is your what? This is your remainder. And as always, you know that this is your what? Your dividend, and this is your divisor, right? So let's keep it right here. I'm going to come back to show you a link between the both of them. Or let me go ahead and show you a link between the both of them. Remember I said that remember this thing I said here? Remember this thing I said here? That divisor times quotient plus remainder will give you your dividend. If you multiply your divisor by your quotient, you should have your remainder. Plus remainder, you should have your dividend. But before I come to that place, let me solve another example. And I'm going to leave one page so that I can return to that very concept I said, so you can see how it links together. Now, next one.
I have a question.
Eh?
If this is now, what is the main answer of this question? Is it that x minus 6 that is the answer?
Yes.
There's a
Remainder. You know, when you
remainder.
divide a number, there's a remainder. Yes. Remainder 2.
12.
Do you get? Remainder 12, rather.
Okay. So you write
Yeah, that
x
would be the.
minus 6 arrow 12. Okay.
Yeah. Yes. Remainder 12. Yes. But that's not the goal of what I'm trying to show you, right? But then just know that when you divide that very stuff, when you divide that very polynomial, the answer is going to be what? The answer is going to be what? x minus 6 remainder 12. That's when you divide that polynomial, x squared minus 5x divided by x plus 1. You give us what? X minus 6 remainder 12. Just like when you divided 19 by 2, you had what? 9 remainder 2. So that's the answer to that polynomial. But there's something I'm driving at. I'm trying to show you what we call the remainder theorem and the factor theorem. But before I will do that, I want to ensure you understand how to divide polynomials very well, right? And if you check something, when you follow this formula that says that your dividend is your divisor times the quotient plus remainder, you're still going to go get this our dividend. Is that also? When we simplify that, so let's go ahead and do that. Hence, we have x squared minus 5x plus 6 divided by x plus 1 will be equal to what? Will be equal to x minus 6 remainder 12. Now, recall that your divisor, that your dividend is equal to divisor times by quotient plus your remainder. So let's check this. Divisor is what? X plus 1. Quotient is what? X minus 6 plus by 12. So this means x plus 1, x minus 6 plus 12. X times 1 is x squared. You can open bracket. I know you can expand now, so it shouldn't be a problem. So plus x minus 6. Is that not so? Then plus 12. So this is x squared minus 5x minus 6 plus 12. So this is equal to x squared minus 5x plus 6. That's your dividend. Is it confusing, guys?
No. This place is not
Yes.
confusing.
I didn't hear you. I didn't hear what you said.
I said that this place is not confusing. This one is like quadratic equation, not confusing.
Yes, good. So now let's go and divide another one again so that it will make more sense to you guys to see how polynomials are divided. Even if it's the only thing I established today, that you guys learn how to divide polynomials, that's entirely fine. Then as time goes on, maybe in our next class, or you can even watch a video like I told you under your factor. It's very simple. I don't want you guys to cram. That's why I'm going through this stress. I'm going through this stress. For you to get the remainder, just x equal to 3, x just are good to go. But I'm trying to kill one stone, to kill two birds with one stone. That's why it looks as though it is a bit tedious. So let's continue so you guys can join your physics class. All right, and next example. I'm going to come back to these questions again, and I will show you something that we mean by remainder theorem. And I should leave one page there, so I will introduce the remainder theorem using that very example. So now, example 2, I will show you guys something. Example 2. Now, see what I'm going to do now. Let's have divide, let's say 2x squared plus, or rather, let's go like this. 2x squared plus 7x plus 3 all over x plus 1. Okay, let's go like this. So solution, please look at what I'm doing. Pay close attention how I'm dividing this whole thing. So as always, we'll have our line, we'll have this, then we'll have this. We'll have our divisor x plus 1. We'll have our dividend 2x plus 7x plus 3. So let's go. 2x squared divided by x. Are you there, guys? 2x squared divided by x. That's the first thing I'm doing right here. So permit me to rule a line here where I'll be taking my steps. This line is like the line that Emmanuel can draw. This one is not like just his own. It's still not straight. Why is my line not straight? My hand is not straight. I think I need to go and eat it. All right, this is better. So now, that said, let's simplify what I said here. So you're trying to do x squared all over x. And this will give us what? Sorry, 2x squared divided by x squared. That will give us what? 2x. Do you understand? So that's why I have 2x right here. The next step is going to be 2x times by x. That will give us 2x squared. So I have 2x squared. Now, the next step you are going to take, please pay attention now, is this is the first step. Let me draw a line. This is just step 1. Now, the second step, you now do, are you there? You now do, come on, no, it's you. You now do 7x divided by x. That will give us what? 7. So you have plus 7. Then 7, sorry, I omitted something here. 2x times x, that will give us 2x squared. Yes, times 1. Good. Thank you. Thank you. You're paying attention. You're paying attention. Then the next one will now be what? 2x times 1, which is equal to what? 2x. So that will give us what? Plus 2x. And that is all. Just one time. Then you do what? You subtract. Emmanuel, are you following now? The way Justice is following now. So you do what?
Yeah.
You subtract. Good. Now, you've gotten the values. So your step 2 now is going to be to simplify them. You do 2x squared minus 2x squared. That is equal to 0. Is that also? That one has cleared. The next one is 7x minus plus 2x. This is 7x minus times plus is minus 2x equal 5x. There are 2 things every mathematics student to know. You see indices, you see negative and positive numbers. Every mathematics student should know it. So now it's very key. So minus times plus is minus. This is 5x. So therefore, what I have here is this place is 0 already. So this will give me 5x then plus 3. Do you understand to this point?
Yes.
Okay. So let's rule our line. Now, the next step now, I'll divide again. I'll divide again like I did in the other one. So let's divide again. But before then, let's see whether I can join this line perfectly well. All right. All right. So now, the next thing I have here is the next thing I have is 2x divided by x divided by 5x. So 5x rather divided by what? By x. This will be equal to what? 5. Then you now do 5 times x equal 5x. Right? Then 5 times 1 equal 5. So that's why I'm going to have plus 5 here. Are you there now? Plus 5 there. Because, okay, x divided by 5x divided by x is 5. 5 times x will give me what? 5x. Then 5 times 1 is equal to 5. Are you there, guys? Now we'll do what? We subtract. So when I subtract, what will I do right here? Anybody confused? I hope everybody is following the way they should. Right? Because as I'm teaching this, I'm praying in my heart that you will understand it. Now, I'm going to have as always, that 5x minus 5x is equal to what? 0. 3 minus plus 5, this is 3, minus times plus is minus 5, is equal to what? Negative 2, which means that our remainder is what? Is negative 2. Do you understand it now? So we have, from our answer here, we have that our quotient is equal to 2x plus 5, and our remainder is equal to minus 2. Do you understand that division now? Do you understand the division now? So I will leave another one page where I'm going to establish something regarding your factor theorem. Now, let's do another division. And I'll be leaving pages. I'm going to come back to that place to introduce my remainder theorem and factor theorem. Example 3. Now, look at this, guys. X cubed minus 3x squared minus 4x plus 12 divided by x minus 2. Soludo. All right. So let's open up what we know already. Introduce this. Introduce this. Now I have x3 minus 3x squared minus 4x plus by 12. Now, what do I have? I have x minus 2 outside here. So this is x minus 2. So x cubed divided by x is what? That will give us x squared. Is that not so? Good. That will give us x squared. Now, x squared times by x will give us what? X cubed. Your normal long division. X squared multiplied by negative 2 will give us what? Negative 2x squared. Then the next step is you do what? You subtract. I will follow you now. So when I subtract here, I should have 12 is going to come down. Minus 4x is going to come down. Then minus times minus is plus. Then minus 3 plus 2 will give us what? 5x squared. Good. Now we go again.
Wait, sir, I have a question.
Yeah, go ahead, Justice.
You said minus 3 plus 2. Supposed to be x there. 1.
No, now. You have minus 3x squared. Minus times minus is plus. Is that also? Or more like this. Let's do like this. Minus 2x squared. So minus 3x squared plus, oh yeah, is equal to what? Minus x squared. Good. You are following. Minus x squared. Tell your sister to give you more. I said she should give you more meat this weekend or today. Is that okay? If she's at home, tell her I said so. That I need more meat today, right?
She will not.
She will not give you. She's not okay. She's not at home.
She's at home.
Yeah, she should give you more meat, please. All right. So let's continue. Now, Emmanuel, are you following? Emmanuel, are you following, Emmanuel? Okay, if you are saying yes, I can't hear you. So the next step now, we'll go again. X by x squared. X squared divided by x is going to give us what? Just x. Is that not so? So when we multiply, we'll have x squared. X times minus 2, that will give us minus 2x. Is that not so? Then here, I'm going to bring down as always. So let's bring it down right here. When we do, we're going to see that x minus x squared. Hope I'm not making any mistake right here. X divided minus, oh sorry, my bad. Here should be minus X. I've seen that error immediately. So did you see the same mistake? This will give us minus X right here. So this will give us minus X squared. I will follow you now. Did you see my error? A thumbs up if you saw my error right there. Okay, so this is minus here. So let's simplify now. Minus X squared, because minus times minus is plus. So minus S squared plus X squared, that will give us a 0 right there, right? It rules out. Let me quickly do that here. Minus X squared, right? Minus X squared. Minus X squared plus X squared, that will give us 0 right there. Now the next one that I have here is what? Minus 4x minus 2x. So minus 4x plus 2x is equal to what? Negative 2x. Is that not so? Yeah. So I'm going to have negative 2x plus by 12. Do we agree? Okay, there's a thumbs up there, which means they agree. Now the next part here, x, okay, 2x divided by x, that will give us an x, right? So I'm going to write a negative x actually, not just x. So this one is a bit longer. I'll have a negative x here. So this is negative what? X. Is it negative x or negative 2 rather? That will give us negative 2 because minus 2x divided by x, negative 2. Negative 2 times 2x, that will give us negative negative 2x. So now negative 2 times negative 2, okay, minus x times x, that will give us negative x squared. I made a mistake. Can we quickly trace our steps back? I have this x squared here, right? X squared times x will give me x cubed. This is minus 2x. This will subtract. Minus times minus is plus. This is minus x squared. X into minus x squared will give me x. X times x squared minus x squared minus x times minus 2x. This will give us plus 2x right here. Are you seeing that now? Plus 2x right there. Okay. So, yeah. So when I simplify, I have plus x. So minus times plus, that's minus 2, right? Minus times plus, that's minus 2. Minus 4 minus 2, that will give us minus 6x right here. So this will be minus 6x. Sorry about that error. This is minus 6x. So which means that what I should have here actually should be plus 2. This is 2. So that will give me minus 6. Emmanuel, you're no longer talking. Maybe you are confused or something. So this will give us minus 6x. Then we divide again. Minus 6x divided by x, that will give us minus 6 right there. So I'll have minus 6 here. So minus 6 times x, that will give us minus 6x. Then I'll have plus 12. And as always, we're going to subtract. So when we subtract, you're going to see something. Minus times minus is plus. Minus 6x plus 6x, here will give us 0. Then this will also give us 0 as well. So that means our answer, the remainder here is going to be what? 0. Did you see that? Is it confusing? So that means that, yeah, Tina, so Emmanuel. So that means that we'll have our quotient. Our quotient is going to be what? X squared minus x minus 6. Our remainder is 0. Just like when you did, my God. Just like when you have 6 divided by 2, 3 remainder 0, right? There's no remainder. So their numbers, if there is a factor of a particular number, you don't expect to have a remainder. Is that also? If that thing is a factor of the other one, it means your remainder should be 0. Do you know what it means? It means that this very number, this very variable is a factor of this one. Because if 2 can divide 16 without a remainder, it means that 2 is a factor of 16. If 5 can divide 15 without remainder, it means that 5 is a factor of 15. So it means that this x minus 2 is a factor of what? This very stuff. So recall, (15) divided by 3 is equal to what? 5 remainder 0, right? This means that 15 is a factor of, sorry, 3 is a factor of 15. Also, we have that very function x cube. We have x cube, right? S cube minus what is that? We have s cube minus 3x squared minus
Minus
4x
plus 12.
plus 12 is equal to what? X squared minus x minus 6 remainder 0. Is that also?
Yes.
Sorry. I made a mistake. Sorry. Also, it means that x squared s cube minus 3x squared minus 4x plus 12 divided by, divided by what? Divided by, let me put this in brackets.
2 minus
Mhm.
x.
Good. X minus 2 rather. Divided by x minus 2 is
X
equal to what? What was our answer? Is equal to,
x
good, x
minus
squared
2.
minus x minus 6. Remember what? 0. So what does that mean? This means that what happened?
It is a factor.
Yes, this means that x squared minus x minus 6 is a factor of x squared s cubed minus 3x minus 4x plus 12. Now let's go back to the first example. After dividing everything, there's a remainder, right? Which means that factor we divided with is not a factor, right? Now observe this. Observe this. Remember that the function they gave us, right? The f of x, that is the dividend, is equal to x squared minus 5x plus 6. The divisor, in bracket, x plus 1. Now, are you paying attention now? Let x plus 1 be equal to 0. What does that mean? It means that your dividend, which is equal to what? Remember, your dividend is equal to what? Remember, we have quotient. Sorry, let's go like this. I'm writing this in a way that anybody can understand it. So now, recall. What do I want you to recall? Please follow through. Like, this is one of my tough class because I'm trying my best to ensure everybody's following. Now, let the divisor, in brackets, x plus 1 be equal to 0. Then we're going to have that the dividend now will be equal to 0 times the quotient plus the remainder. Are you seeing it now? 0 times the quotient plus remainder. So it means that the dividend, I'm going to show you what this implies, is equal to what? R. What does this imply? We have that x plus 1 is equal to 0. So that x is equal minus 1. You have the function f of x to be equal to, let's plug in s squared minus 5x. So s squared minus 5x plus 6. So that f of minus 1 is equal to minus 1 squared minus 5 minus 1 plus 6. F of minus 1 is equal to 1 squared minus 5 minus 5. What was the remainder for that question we solved? For the first question, was it 12?
12.
Yeah, 12, right? All right. So we have, and we're divided by x plus 1. So I'm trying to observe something. I said plug in x minus 1. So minus 1 squared. Oh, I know. Yeah, x squared minus, this is plus 5. Is that not so? Then plus 6. So I'm going to have that f minus 1 is equal to 12. Did you see what happened now? Can you observe what happened in getting the remainder without dividing it? Justice,
Sir?
did you see what happened now?
Yeah. Yes.
Are you sure?
Yes, yes.
So, Emmanuel, are you there? So without dividing it, we have our remainder. So it means that if you ask me to divide something, if I'm asked to divide to get a remainder of a particular function, I don't have to go through this long way of dividing it. I don't have to go through that long method. So what I need to do is to equate the divisor equal to 0 and then plug in the value of x inside that very equation, and I have my divisor and I have my remainder.
There is no other way to get the
So now,
question.
I didn't hear you.
Since we could get the remainder, is there any way to get the question without doing that stuff?
No. There's no way to get quotient. You have to still, unless you have the remainder. If you have the if they give you the remainder, yes, you can. You can use this formula now. If I know the divisor, are you paying attention now?
Yes.
If I know what I'm dividing, I know the divisor, and I use this method now to get my remainder, I can solve for my quotient now without using that long division.
Okay.
Do you get?
Okay.
So the once you know your remainder, I can get the quotient using that very method. But sometimes it might be very long to solve, but it's very possible to do that. Does it make sense?
Okay.
So good. So what does the remainder theorem trying to say? What does it say? That without doing that long division, we can get our value. So your remainder theorem simply says remainder theorem is saying that let fx be a polynomial of degree greater than or equal to 1 And then let A be a real number. Hmm? So when fx is divided by x minus a, it means that the remainder equal fa. That's what happened here. Are you seeing that? Your remainder was equal to f minus 1. Did you see that? Remainder was what? F minus 1. So when you plug in that value, that's actually your remainder theorem, right? That's actually your remainder theorem. So example, e.g., let's say, what is the remainder find the remainder, find the remainder, the noise, justice, the noise, when, I think it's from your end,
I'm muted already.
when 2x plus 7x plus 3, when, okay, let me take this, let me just copy this and save stress. Yeah. Find remainder when this. So what will I do? Like I told you. So solution. Remainder theorem. You have x plus 1 is equal to 0. X equal negative 1. So factor in f minus 1, right? Remember that your f of x is equal to 2x squared plus 7x plus 3. So that f of minus 1 is equal to 2 minus 1 squared plus 7 minus 1 plus 3. So
Sir,
f
please,
minus 1.
sir, please, this f of x, what does it mean? Like you said, f of x.
Is a function. Like f of x is a function, a polynomial. You can call it p of x, f of y, anything you want to call it. It simply indicates
Okay.
that this is a polynomial. Does it make sense?
All right. All right.
All right. So now, that said, we have that f minus 1 is equal to 2 minus 7 is minus 5, right? This is minus 5 plus 3. So f minus 1 is equal to what? Minus 2. So what does it tell you? It tells you that the remainder is minus 2. So it means that f of a equal your remainder. And look at what happened here. Is it not the same thing? Your remainder is not minus 2. Did you see it now? So if you're asked to, that's how we make use of your remainder theorem. Without dividing, you can plug in by making x subject of x equate the divisor equal to 0. Once you equate divisor equal to 0, you simplify, right? You will get the remainder. Idea. So hence, So you don't have to divide again. You can do that. So with this example as well, I use this example to show you the factor theorem. Remember theorem for that. Is that also? Now, another thing I want to show you is what we call the factor theorem, right? So you can see that after dividing this one, we'll have the remainder is 0, right? So that is a factor of this. Now, observe this as well. Observe. Are you there now? Observe the factor theorem. If I do, we'll have the divisor is equal to what? For this one, x minus 2. So divisor equals 0. That means x minus 2 equals 0. X is equal to 2. Now the polynomial, the dividend, in bracket, the polynomial is equal to f of x. And the f of x is equal to, call it for me. Someone call it for me. So that I can write without looking at going up and down. S cube minus what? Anybody calling it for me? Nobody. S cube minus
3x squared.
minus 3x squared. Yes. Next one.
4x plus 12.
Minus 4x plus 12. So we have f, plug in that 2 right there. So when you plug in 2 right there, so this will be equal to what? I have 2 power 3 minus 3 all squared, 2 squared, minus 4, 2 plus 12. So this is equal to 8 minus 3 to the power of 4 minus 8 plus 12. This is equal to 8 minus 12 minus 8 plus 12. This is equal to 8 minus 8 minus 12 plus 12. This is f to 2, f to 2, f to 2. So this means that f of this one, man, I didn't respond to his call again. I should check it out again. So f2 is equal 0. Do you see it now? So if you have that function equals 0, it means that that very divisor is a factor of that polynomial or that function. It means it's a factor of that function, right? Hence, divisor is a factor of the polynomial. Are you there now? So this gives birth to the factor theorem. So factor theorem says that if I plug in that function, that very divisor into the polynomial, if it gives me 0, that means that that divisor is a factor of that very guy. Do you understand it now? A thumbs up if you understood what I said now. Good. So let's look at your factor theorem. If this is a polynomial, of degree greater than 1 and A is a real number such that f of A equals 0. Are you there? Then x minus A is a factor of f of x. Is that okay? So you can say conversely, if x minus A is a factor of f of x, then f A is equal to 0. Do you understand it now? So for example, then we'll call it a day. Example, so that x plus 5 is a factor so that it is a factor. Are you there? So that x plus 5 is a factor of x squared plus 3x minus 10. Solution. So how do we show this without dividing? How do we show this without dividing? It's possible, right? We can show this without dividing. So what we can
Yes.
do, we say that good, that f of x is equal to
X
x
is
squared.
minus 5.
Good. So now we have x plus 5 equals 0, x equal negative 5. So we'll plug that in to check that it is equal 0. So f minus 5 equal minus 5 squared plus 3 minus 5 minus 10. So this is equal to 25 plus, sorry, not plus, 25 minus 15 minus 10. So this is equal to 25 minus 25. So this is f negative 5, f negative 5. So f negative 5 is equal 0. So you have that since
So I think that
f
25 should be minus 25.
where
That's 25. That's 25. 5
that's
minus 5x squared is minus 25.
no 5 minus 5 to minus 5 is 25 now, because minus 5 times minus 5 will give us minus times minus is plus.
Okay.
Yeah. Is a factor of the polynomial. All right, so try this. Check this. Hmm? Check this. Okay, sorry. So let's say that if x squared minus 4x squared plus px plus q, this is the kind of thing Jam will ask you, is divisible by x minus 1 and x minus 2, find p and q. I want to try this one out. Check it. Get your hands dirty and tell me what you think. If it is divisible, that means it divides without remainder. That means those two numbers are factors of that very stuff. That's what it means.
Let's give it a
Are we
try.
together?
Yes.
Yeah, just give it a try.
That's clear. Then x is 1, x is 1, x is equals to 1. 1 squared minus 4 bracket. Okay.
So what do you have?
I have remainder as 3 when x is equals to 1.
You said?
Um, when x is equals to 1, as in when the f of x is equals to 1, I have as my remainder 3 plus p 1 plus q.
Mm-hmm.
Then let me check
No,
for when x is
no,
equals to
I
3.
don't. Write it down now. Solve for
Okay.
P and Q. Anything you get, you solve them now.
Uh,
Meanwhile, that will lead you to a simultaneous equation anyway. So when you solve, you can send the answers to me on the chat. It's time for their biology class. So all the best, guys. I hope you understood everything that we did today. So send your answers for P and Q to me, right? I think I've handled this today. I've looked at factor and remainder theorem. Even I think today I also did multiplication and division of polynomials, right? I was treating factor and remainder, and I touched that multiplication and division. So it's up to us to go look at factorization of polynomials shouldn't be a problem. You should know how to factor polynomials. You should know how to get the roots. So all the best, guys. I will see you out on Thursday. And for Thursday, I think we should do more on Thursday so that we can cover up these polynomials and then look at binary operations. So I'm going to look at binary operations on Thursday. All the best, guys. If you have any questions, do well to ask me. Okay.
all right. Thank you, sir.
Justice and Co. Yeah, send to me on the chat.
Okay.
All right.
Oh, well done, Mr. Lutachukwu.
Yeah, thank you so much. He's coming to end the recording so that you can start. Okay. Thank you. How
No
are you doing
problem.
now? All
I'm
right.
okay.
Welcome. Okay. Please take note of the students, the attendance. I'll be leaving shortly. I will not come again to check on them.
No problem.
All right. Thank you so much.
Yes. Gift, hope your head is not overeating. I want to start chemistry after.
No, she didn't do maths. She didn't do maths. She didn't do maths.
Okay, that's good. All right. Then. So let me just give you guys 2 minutes to quickly readjust to your chemistry. Bring out your notes and check the last topic we treated. I think many of you had issues with the last topic, right? The
Mr.
bonding
Kunle,
and
I think you're an co-host. Can you end the recording for my own so you can start again? I'm not using
okay,
my laptop.
okay.